Hello everyone, welcome back. Today we are going to start the topic of exponential function. In this lesson, we are going to briefly discuss what is exponential function and what are the models we are going to have for this type of function. Before that, we're going to discuss some real-life examples we actually see in our life. The first one, I know the picture is a little bit nasty here. So you can see when we store the food, and sometimes over the time, if we do not store in the proper place, like if you do not put in the refrigerator over the times, there will be mold in the food. And the number of mold increasing and the way it increasing actually can be modeled by using exponential function. So basically, the number of mold is not going to increase like linear function, like getting just like this way. But it's actually very slowly increasing, but very quickly it's going to go up very high. So this situation can be modeled by exponential function. Another example is some picture regarding, for example, we just experienced a pandemic, and over that time we know the disease spreading among the people increasing very, very fast. And that situation can also be modeled by exponential function. It's like from the one person to spreading two person, but continue, then it will increase by very, very quickly. So the way we increases can be modeled by exponential function. That's basically it is. And we can also quickly see another two example. In general, when we sell the car, for example, you purchase a car, and even you want to sell the next day, or you want to sell next week or next month very quickly, most likely the price will go down. Another situation is if you purchase a house, and years later you want to sell it again, then most likely the price will go up. So that's why a lot of people consider that's a very good way to do the investment, because the value of the money does increase. As you can see, so based on the example we just discussed, we're actually expecting to see two type of models. One is called exponential growth, which you can see is increasing very fast. And the other one is called exponential decay. And the word decay here indicating is decreasing. So the value is actually getting lower and lower, but it's not linear cases like this. Instead, it's getting like quickly, and then slowly decreasing. So then what type of function, what kind of, a formula or equation we are going to use to describe the growth or decay? Let's check this. So we do have two models here. One is called exponential growth. The other one is called exponential decay. And as you can see from these two models here, the two models is actually very, very similar. The only difference here is one is plus, one is minus. But what does that mean for each letter? A meaning initial amount or initial value or starting value. So you can always think about this one. And R here meaning rate. But based on the different models, in this case we call growth rate, and T meaning over the time. For example, we purchase a house, then 5 years later, what's the price for the house? We can use this model to predict the price of this, and T time in this situation is meaning 5 years. And you can see here, every single here is similar, and since R in the growth situation, we call growth rate. Then for this one, we call decay rate. It's just a different name, but it's a rate we are talking about. Now we are going to practice two examples. So in next video, we are going to practice two examples and to see how do we use exponential growth and exponential decay to solve two real life problems. Okay, see you soon, everyone.